Well, good morning, and welcome to this little Nautel webinar on ATSC 3.0. I'm Fred Baumgartner. I'll be speaking at the end of this, and I'm your host. And we have a guest today, and that's Schelle. So what we're going to do is we're going to start with talking about ATSC 3.0 and Pearl. She is the managing director of Pearl, which is a partnership between broadcasters to develop the next generation of TV, and it doesn't get much more exciting than that. And Anne has quite a history and a lot of experience along these lines. She was the executive director of the Open Mobile Video Coalition, also a senior advisor to the NAB for years, and she's currently on the board of the ATSC herself. And we were just comparing notes before we talked, and we both go back to the early days of telecom and Macaw and MCI and Air Signal and Sprint Spectrum and things like that. And it's just interesting how the technology kind of all melds together. When she's done, we'll take a little Q&A here, and then we'll get into my section, which is a bit more technical. We'll talk about the standards process and the key concepts, and a little bit about Nautel transmitters also. So with that, I'm going to throw it over to Anne. Welcome.
Thanks, Fred. It's a pleasure to be on this webinar today. Thank you for inviting me. I represent, if we go to the next slide, a consortium of media companies in the U.S., local broadcast television stations, 9 of them. You can see them listed there. We cover over 2/3 of the U.S. households and currently book over $5 billion in ad revenues. Pearl was formed in 2010 to take advantage of our collective assets as we look towards innovation requirements in both digital and over-the-air applications. Again, looking at our distribution of our local broadcast television content in the U.S. as consumers are moving cross-screen. One of the key areas that we've been focused on for the last 3 years has been the development of the next generation, or ATSC 3.0 television platform. We're really excited about this standard. As you know, the ATSC is the U.S. standardization body that developed the current television standard. What we like about this standard is we see it as a new platform. It's a platform that allows us to enable an IPTV-like environment. It's IP broadcast television. So it brings the linear at scale into an OTT world. It enables a hybrid simulcast with a return channel. It uses spectrum efficiently. Fred will get into the technologies. That's important certainly in the U.S. as broadcasters are in the midst of a spectrum auction, and we will be enabling this new technology on top of our current technology, and I'll talk about what I mean by that further down in the presentation. This increased capacity, though, also brings the ability to offer more services and more channels. Multicasting in the U.S. has been doing fairly well over the last couple of years. The other key attributes is a better consumer experience, so what I call bigger, better picture, with ultra-high definition and HDR capabilities, enhanced audio capabilities, the ability to add repeaters. This is important to enable a robust indoor signal as well as mobile signal. These are all inherent in the standard. Emergency alert system functionality that's much more robust than what we have today, even being tested by FEMA in the United States. Because of the return channel environment and the IP environment, as well as many of the internet technologies that are out there today that are built into the standard, will allow broadcasters to keep pace with what's happening in digital and enable targeted advertising. We think this addressable advertising, the ability to deliver ads to audiences, is something that's growing as a requirement for brands and agencies, and we'll be able to keep pace with our digital competitors. A greater control over ecosystem. This is a very flexible standard, the way it's built, and Fred will talk about this later. This is our last standard. We won't have to go through the same process of having to retire an old standard to get to a new standard. It enables signaling at the very base layer of the physical architecture. I call it a soft radio approach. It's probably not the right terminology, but the point here is that we don't know where the future is going in this ever-evolving ecosystem as consumers continue to have a voracious desire for premium content. They want to view it where they want and how they want. So again, this platform enables us to enable that viewing structure for consumers. And I think we can go to the next slide.
By the way, I like that soft architecture. That's a good way to describe this.
Yeah. Well, you know, soft radios have been like a technology that's been sought after and also in wireless, and I think we kind of got that concept somewhat here with 3.0. One of the things that Pearl's been doing over the last several years is start to understand, you know, in this current ecosystem, we really have to have a consumer perspective. We can't go at this just with what broadcasters think would be good for the consumers in the marketplace. So we did a survey with our partner Sinclair Broadcasting right prior to NAB and asked consumers what's attracted to them. This is just a very top line from the consumer survey. I'd be happy to share more of this for the folks that are on the line separately through Fred. But, you know, again, consumers are used to, you know, with the advent of the iPhone, they're expecting better all the time. So it's important for broadcasts, specifically live over-the-air broadcast, to keep pace with that expectation. That includes better picture quality, more channels. The free-to-air component of more live channels is very attractive to consumers. The high-quality audio, and this is something I didn't expect in the survey, it is immersive audio. If you were at the NAB show, didn't get a chance to see Dolby's presentation of this, it's an interactive audio feature as well. Consumers loved it, the concept of a 3D-like environment or movie environment for audio. Other obvious attributes, the interactive nature, the hybrid nature. Consumers want, you know, really easy use. Netflix is our bar these days, so that, you know, enabling a consumer to easily go between their live and their broadband experience is really important to them. The enhanced emergency alert aspects also high. You know, again, targeted advertising. Of course, we always ask that question. Consumers typically will say that they prefer to receive advertising that's relevant to them. We move to the next slide. So, you know, I always get the question, well, you've got, you know, 5G coming along, you've got, you know, the broadband service providers and our cable brothers, so you know, we certainly are partners with them, the OTT environment rising. So how does this play out, the 3.0 platform with the current ecosystem that's out there? And I attempted to do this in this slide just to show the attributes that are in 3.0. You know, again, this in a full build wouldn't be here for at least 5 years in the United States, but the attributes of the platform are incredibly attractive to broadcasters, and the option to be able to do this is something that broadcasters have, obviously we've developed a standard. Fred will talk about it's, you know, where it is currently, but you know, we filed a petition at the FCC. It was put out for public notice. There were no broadcasters that filed in opposition. It was all positive. There were some comments made by some players in the ecosystem, but nothing that was insurmountable. How we approached this was an optional add-on to what we currently have. We see doing both 1 and 3 for a period of time as devices get on shelves, the consumer uptake as we understand the business models around 3.0. But, you know, here's an attempt just to look at sort of what are the attributes that matter and how do you rack and stack those against the competitive platforms that are out there. again, these platforms will also be moving along in the next 5 years. I want to move to the next slide. So Pearl it looked at what are the revenue opportunities on this new platform, and we retained FTI Consulting to do this work for us. And we focused on 4 key areas that we feel really matter, and you actually can look at them in a timeline perspective against a build. So first and foremost, what I talked about, the consumer interest in a bigger, better picture, increased viewership with additional content. You already see in the U.S. Sling announcing a free antenna that they want to put in their Sling box, Xbox putting an antenna in, Cablevision selling antennas in New York with their authenticated broadband direct-to-consumer application for Cablevision. So, consumers looking for options. So this is really enhancing our core business for over-the-air broadcast. I'll talk about what that revenue opportunity translates to. The second piece is advanced advertising. I spoke about that earlier. Targeted advertising, the ability to deliver audiences and enable programmatic ad sales. Again, I'll say that in a TV ecosystem, we are not looking to erode our businesses there, but we do think that there's opportunities to grab digital and advertising that we're currently not getting in the TV environment, and certainly staving off ad loss. Interactive advertising, there's the capabilities of doing interactive on this platform. That's something that the TV industry has been talking about for a long, long time. This actually would enable it in a live environment. If you go to the lower left side, this is furthest out. We think these ancillary services, skinny bundles, automotive connectivity, you need a national build for that. And the right lower quadrant or pie slice, this is an interesting one. This is wholesaling data capacity. Fred will talk about the PLP, the pipes that are enabled on and the flexibility of different throughputs and on this platform. You've heard Akamai come out and talk about this new platform, really looking at it as CDN to the home. The ability to offer consumers alternatives to their current distribution platform downloads. Netflix, for example, could offer a cheaper way to get a carousel of content over our platform versus what they would deliver over the broadband connection. So some really interesting opportunities. Think back to the days of iBeam and others. I think you've got a ready market now with consumers really interested in video and premium content more than they ever have, and also the amount of content that's out there. Next slide. So what did those dollars translate? In the FTI study, the revenue upside was pretty large over the time period that they have here, 10 years. Incremental upside of $20 billion. What if you stay on 1.0? Potential loss risk of up to $12 billion. These are very directional. This is assuming a national build and SFN in some cases. And so, a base case is that line in the middle. But certainly it's an improvement over what we have today, and staying on a 25-year-old technology is something that's not adaptable, is something that we feel strongly is not an option. Again, though, our current businesses are good businesses, and our plans are, if we move to the next slide, our plans are to enable, and you saw this in our petition that we filed. It was NAB, CTA, so the manufacturers, public television stations, APTS, their association, and AWARN, an Advanced Warning Alert Coalition, filed at the Commission the concept of of enabling a host station. This is a market-based, broadcast-led initiative, very different than the last HD transition where it was government-led. Here is broadcasters asking to be able to enhance our current systems with this new capability. The way that we would find spectrum, there's no we're not giving ready spectrum in order to do this. We would enable through sharing agreements on a market-to-market basis what we call host or lighthouse stations that would implement the first services for 3.0. Because of the compression technologies on 3.0, you can stack multiple high-definition HDR signals, ultra-high def, and be able to transmit out the services as what we call sort of a starter service environment. To do that, broadcasters do have to collaborate, but they are doing that already. So if you look at the channel sharing agreements going into the auction or that will come post-auction, those are a benchmark and a way that you can see the broadcasters can enable this. This is a timeline. I mean, it's we're moving some of these arrows. Obviously, as we don't know when the auction will end. We also don't know what those clear targets will be, but certainly it's, I think, fairly directional in terms of the timing of the progression of the standard. The standard itself will be done by the end of this year. ATSC activities around the standard, that's implementation and guidelines to how to build. That's why the arrow goes out further than that. Testing and validation, that's already occurring. NAB is setting up test stations. You've got Sinclair with its SFN build here in Washington, D.C. The obvious development of transition plans, business models, the consumer value proposition. I touched on that earlier. There's work being done on that. So a whole ecosystem needs to be established around this, and the organizations of ATSC, CTA, NAB, and the broadcasters in the U.S. are working on that. Next slide. So this is this concept of the host station build. Pearl has done an enormous amount of work at looking at capacity constraints. How do you develop the agreements that would be required? Our petition before the FCC asked for the rights to do this. And we feel pretty confident that although it is complex, we will be able to enable this. And frankly, it's something that broadcasters would look to do as part of the repack. So again, it's this concept, I call it a lighthouse station here in our petition. It's a host station. We would enable cost pooling. There are benchmarks for this in Europe, how stations multiplex and statlex themselves. So I think you're going to see more of that here in the United States. That's a good thing because just like the carriers, we're not necessarily in the business of owning the infrastructure. Our business is distribution and creation of content. So that's how I think you're going to see it play out. As we move forward to a notice of proposed rulemaking in the U.S. and the end of the auctions, I believe you'll start to see test markets launched for 3.0. That would be in the mid-2017, close to 2018 timeframes. And that's all I had for right now, Fred.
That's excellent. Before we switch over to our deck here in questions,
I do have device concepts. I don't know if you want to go through those. I forgot I had these slides on here. I apologize.
Can we save those?
Yeah, let's save those. Yeah.
Okay. Well, let's first see if we've got any questions on there. But one key thing is that a lot of our audience is still thinking about the DTV transition and how difficult that was, and how we dragged people through the process because it was basically a government-driven thing that said thou shalt turn to digital, and there wasn't much in the broadcaster except expense and pain and sorrow in it, and difficulty getting the audience back afterwards. And ATSC3 is the exact opposite, because this allows the broadcaster to open new lines of revenue, new services, and compete with the ever-growing internet. It literally puts the broadcaster into the position of being a mobile network operator, which is a complete change in the way that broadcasting works. And the other is that with the tie to repack here, potentially, as you say, we don't know how many stations are going to go away and how the repack is going to work out here. But if the maximum number is taken, that takes away 21 UHF frequencies here, leaving only 17. And what ATSC3 would do would be allow you to get that bandwidth back, especially with the high efficiency that you can achieve with single frequency networks, where you're not wasting a lot of that spectrum on rebroadcast and whatnot. Can we take a look at questions? Do we get any from the audience here? Matt, are you still on the line?
Yes, I am. Can you hear me okay?
Yeah,
okay,
I'm
cool.
good.
So the first question was, can you confirm that the iPhone will be supported by ATSC 3.0?
You want to take that, Ann? Ann, are you still there? Oh, we may have lost her. Answer? We don't know yet.
Don't know yet.
That's,
okay.
Yeah, you'd have to be in the mind of Apple in order to figure that one out. Place your bets.
Okay.
One would have to think that.
The next question is, Anne mentioned, I believe, that this is the last platform. Can we be sure? Is this because it's adaptable?
Yes. Yeah, the point is that once you get to, Anne, are you out there? I'm going to presume that we've lost her. I much appreciate what she said today. She's muted, or?
She's there, but for whatever reason, we're not hearing it. But you can keep going with the question. Okay.
Yeah, the beauty of being an IP platform, remember the old ATSC1 was locked at 19.39 megabit. There was no other flavor. There was no realistic option for doing single frequency networks in the same way that you can with an OFDM modulation, where there's literally no interference between the booster transmitter and the main. So that part of the platform is pretty solid. You can't get any better than perfect. But the IP part lets you change out what your applications are going to be, because it's a multimedia platform. ATSC1 was stuck with the codec of the day, MPEG-2. We'll start with high efficiency video codecs. If codecs get better, if they go to 3D, if they do anything, once it's on an IP platform, you can update that as you go forward. So it becomes the ultimate. It would be like saying, will the internet be outdated? It's just hard to imagine that the internet would be replaced by something. It's once you've got a very open, flexible protocol to work against, you can do just about anything.
Cool. The next question, will ATSC 3.0 TV receivers be backward compatible with existing receivers?
So far, everything we know from the CES world, I mean, this is very early. Only pieces that are really there are the physical layer, the transmission standards are done. So the early, prototype televisions usually do ATSC 3.0. The ones they're using in Korea, for example, which is really the first setup for ATSC 3, do both ATSC 1 and 3.0. There's really ATSC1 is a lot easier to do than 3.0 is, and in the 25 years since digital television was first conceived, the ability of silicon and software has increased so dramatically that it's like falling off a log to go back and do an ATSC1 decode. So I would anticipate that they will for some time. Whether or not they'll pick up NTSC, that's a whole different question. We see a lot of consumer televisions now dropping any kind of analog video support.
Ann is back, Fred.
Oh,
yeah,
okay.
Maybe we can ask the question about iPhone support.
Didn't like my answer, did you? Go ahead, Ann.
No, I apologize. One of the things that, I dropped off because my internet went down, so go figure. That's part of the reason why over the air is good. Here's a perfect example, and then your video crashes if you're streaming it. There's a big difference in this being a digital to digital conversion also. So the infrastructure that's currently in stations largely can be reused. As where the workflow in stations, and the same with the I think the same with the devices themselves. So smart televisions, the OEMs will be adding just a second receiver chip. So they'll have 1.0 and 3.0 in the receiver chip. It's not like the early days of HD where the TV set cost $20,000 when it first came out. It's going to be an incremental add. It's very, you know, it's using a lot of the same components in the television. So those are some of the differences also folks should be aware of. So you could create an easy dongle or a gateway or that could take the various devices in a person's home and convert them. So it's a different problem set, but a much easier one to solve in terms of converting consumers in the marketplace to a 3.0 environment.
I think that's one thing that the world misses, is that they overestimate the complexity of going to 3.0. Ideally, the simplest, most basic one for a granny TV, what you've got hanging out on the wall, may be a $29.95 dongle with a 75 ohm connector on one end and an HDMI on the other. Would you agree with that?
Yeah, absolutely. I don't know $29.99, but given Chrome's prices, certainly. And you know, there's all kinds of models because you can use the back channel, and there's this you know, it could be a sponsored dongle approach. It's sponsored, and you know, or you have a big player come in to distribute it. So there's all kinds of ways to approach the transition for consumers. But what we're seeing now is, you know, why call those out? Let's enable a host station next 3 years here in the U.S., start to launch these services and really understand that this platform offers benefits on the core side of our business, and start to build the platforms required for the advanced advertising, the targeting, the interactive, conditional access, et cetera, that would allow us to have access to pay models, to the ability to offer more products and services, more channels, more content, skinny bundles, etc.
Excellent.
We've got actually one more question that just came through. I'm not sure if you just answered it, which is, will the consumer devices need to be updated as the platform changes? Will this be designed into the devices initially?
So that's that concept I mentioned earlier of this is the last standard we would have to go through. So just like today, when you buy a 4S, or it doesn't have LTE5 in it. I don't know what lineup on the Apple's devices, but it still continues to work. Similarly, you could add 8K, 22K, and all kinds of capabilities 8 or 9 years from now, and the first TV set, the 3.0 set you buy 3 years from now, so 10 years later, your 3.0 will still work. You just won't get those extra features. So not unlike, I'm lazy, I haven't upgraded my iOS, but my phone still works. So if you know, that's up to the consumer, but they will still be able to receive the picture. Unlike 1.0 is not backward compatible. 3.0 is not backward compatible with 1.0. That's why we're running two systems at the same time.
For the transition.
Right.
Yeah.
I'm afraid we got one more question, and then we'll pause the question answering, and then we'll switch back to Fred. So speaking of these new TVs with chips to receive both 1.0 and 3.0, is it likely manufacturers could configure these new tuners to auto-recognize whether the incoming signal is a 1.0 or a 3.0?
You need the two tuners in the television shot because they're very different. They would be receiving the simulcast feeds, so you can't have one tuner that does both. So the 3.0 would pick up any 3.0 signals in the market, and the 1.0 would pick up any 1.0. From a consumer's perspective, they don't. The UI itself would have, just like today in the U.S., you've got a bank of HD channels versus SD channels still. So the consumer would see, this is the next gen, however it's branded, and they would hopefully be watching more frequently on those because they could do more, and that's sort of your path to migration, the consumer pull that we think will be there once they see these new capabilities. I hope did that make sense?
Sounded good to me.
Yes, to me.
So why don't I hand control back over to Fred again, and so Fred, if you get your desktop ready, we'll switch over to your screen.
I'm hoping it is.
And I will mute myself.
And you can stay, or I know your time is very valuable. We don't want to compromise too much of it. I really appreciate you being here today. Thank you very much.
Thank you. It was a pleasure. And if the folks listening would like a copy of the slide deck, happy to send that out, and also the consumer survey if that's helpful.
And I'll certainly pass anything they send to me to you.
Okay. All right. Thank you so much. Thank you for having me. Sorry for the technical.
Thank you.
Thanks a lot.
I'm afraid the technical isn't quite as exciting. Let's start out with this. The technical side of this is an awful lot about standards and timelines. So this process that began back in 2010, the point we are in it is that a bunch of the standards have already been put into places, so they're actually starting to make the products that go around it. And I know standards are boring as all get out, but let's explain just a little bit about how this works here. There is this common ATSC 3.0 parent standard, and within it there's a whole series of other standards, and they're all designated A3 something, 301, 302. You might recall that in ATSC 1 it was A53, and then in the next generation was A153. Well, this follows the same kind of nomenclature, so when you see these standards floating around, you can pretty much figure out that if it's a 300 series, it has something to do with ATSC 3.0. I'm going to say right off the top that there's two kind of views to this. One is technical, and this is a little bit of a joke. It's 10 dB better. In order for a new technology to take off, it has to be significantly better than the one before, and in this case it really is. And then there's the art and the business of TV, and this kind of makes it a brand new medium. Traditional television, you well know, internet, interactive, multimedia, you also well know. This takes us from TV into multimedia at the end of the day here. So let's talk about the tech side a little bit. We'll start out with some really big, strange concepts that you just have to get through. And the first one is it is not backward compatible, as Ann said. An ATSC 1 receiver will not receive anything ATSC 3.0 does, but you can of course build an ATSC 3.0 that has the silicon and software to support essentially two tuners, whether those are virtual or physical, whatever. So they'll be compatible for a time. What it really does is it's meant to feed either a router, not a TV. This is not 75 ohms to your television anymore. It feeds the router that the house sits on. So it puts it on your Wi-Fi network, so all of the devices, all of the TVs, all of the everything in your home, and you can build a DVR into this that everybody shares. I mean, this is the ultimate television experience. So you're not throwing out a bunch of televisions at the end of the day. What you're doing is you're throwing out a router at the end of the day to put a router in that has that 75 ohm connector that can take these PLP feeds, and we'll explain what that is in a bit. And the other extreme on this is that the basic television could be something as simple as a dongle. It might not be $29.95 to start with, but you know Moore's Law. It seems unlikely that's going to take very long. And the part that we left out is that mobile devices part in the middle here. Well, one of the parts about ATSC 3 with the use of single frequency networks and literally carpet bombing urban corridors with signal is that ideally in the same places that a cell phone would work, a mobile device would also be able to receive these signals. And you see there's a bunch of errors here. There's an IP upload. Anything but the granny television can talk back to the television station. It can get special feeds both via IP over your regular ISP, and it can also take it over the OTA pipe. The beauty of the OTA pipe is simply that there is no throttling, there are no ISPs involved, there is no congestion, there is none of the exciting experience we get when we try to do things like the Super Bowl on the internet, which just simply can't work. Very fat pipes. There is no adaptive streaming involved. I can send a 4K and know that that 4K picture made it all the way home here. So the overview of the system, and we'll look at things that look like the OSI model. In fact, this one, the top 4 pieces here, are straight from the OSI model. But it starts at the very bottom here with that system discovery and signaling. This is done, so is the transmission layer here. And now we're working on the protocols, the presentation, and eventually the applications, which is, of course, the part you see as a viewer at the end of the day. So let's talk about transmission for a little bit. We all know and love the Shannon limit. That's the blue line that's going across here. Right down here is the current system, that's A53. This was a 153 that was meant for mobile under ATSC 1, so it gets a little closer to the line. These pretty red dots here are all of the modes that fit with an ATSC 3.0, and this is DVB-T2. So they've managed to actually make it a bit better than DVB-T2, tweaked on the modulation again, but you can see we're getting close to the theoretical limit. All the Shannon limit is about is that how much data can you have for a given amount of noise. And we're always fighting noise in the system and distortions in the system here. And there is a limit where you can no longer decode any of the information. And what we're saying is that under ATSC 3.0, we're about as close to the Shannon limit as we think anybody can practically get. It is OFDM. It's another basic in here. So single frequency networks add, not cancel. This isn't like trying to do a repeater on AM or, God forbid, FM. The deal with OFDM is that as long as you're within the guard interval, and you can pick how far the SFN boosters are apart here, they add, they don't subtract from each other. The symbols land on top of each other and they're decoded. So more is better. You can put 30 boosters in an area if you want. And this, of course, is a little joke. I'm an old media flow mobile guy, and this was our first shot at mobile television. Single frequency networks, very quick explanation. Under the current 8 VSB that's part of ATSC 1, it burns up an awful lot of spectrum. It doesn't penetrate, and it's very poor at mobile. They tried to make it work with something that they kind of called ATSC 2.0 or mobile handheld. But the reality is that, without making the jump to OFDM, it just doesn't make any sense. The new ATSC 3.0 is really good at mobile. It's very different in a distribution network in that it's composed of 3 components. You have the boomers, that's the station that you built on top of the mountain, that is your current coverage. It has boosters you can put anywhere inside that basic coverage area, and DASs. And DASs are distributed antenna system where you can push the signal at low levels into venues and things like subways and tunnels and things like that. So you can continue coverage, because the expectation is that this is receivable everywhere my cell phone works. So I want it to work in the elevator in the big building at the end of the day. SMPTE put on a nice little slide here, which we borrowed. ATSC 1 over on the left here, as we said, is married to that bit rate. It has 1 coverage area, and it has not a whole lot of service flexibility. It can do HDTV, etc., but not a whole lot else. ATSC 3.0, and we'll get into these pipes here in just a little bit, has a flexible bit rate and a coverage area. You can design it. It doesn't have to be a circle. It doesn't have to be an antenna pattern. You can use those SFNs to create any kind of coverage you want at the end of the day. It's got optional on-channel repeaters that make that all possible, and you can do multiple simultaneous bit pipes with different levels of physical robustness at the end of the day. Bottom line is that it moves more bits to more places, which is good as it comes on after repack, and we lose an awful lot of spectrum. The cool thing about SFNs is that it's built with low-power boosters, a whole lot of them potentially. And there's a lot of architectures along the line here. I'm not going to talk a lot about that today here, but it happens. Nautel is in the business of making low-power boosters, and we will follow the ATSC 3 as it goes here and customize the equipment to be able to handle it. And we've already talked to most of our suppliers, and we know that everybody's dedicated to making ATSC 3 work. In fact, this is one of those strange instances where it's hard to find anybody that's opposed to ATSC 3 except possibly for the ISPs who are losing data traffic and the multi-channel video carriers because, well, this competes directly with them. If you're curious what a DAS looks like, this one's down in a subway tunnel in New York, actually. But what it is tiny little transmitters. DASs are used for cell phones, sometimes even for broadcast, and basically they take a piece of leaky coax and they feed it. I'm going to talk about layer division multiplexing. There's a couple of things that there's built into the standard here which may or may not see use right off the bat or ever for that matter. So there's a bunch of debates going on about layer division multiplex at the moment. And basically what you do is you're sending the signal and then 5 dB underneath it, which is a magic number, you send another signal, and the way you decode it is simply this. You decode the strong signal first, it has capture effect on it, and you develop that stream, and then you subtract it from what you're receiving, and what's left is the B stream or potentially even the C stream. Now isn't that cool? Because basically that allows you to double the amount of data that goes through the system. Now of course there's a price to it, is that the second stream isn't anywhere near as robust as the first one. So if I'm trying to hit mobile devices, I'm going to put all my content in that first strong stream, and I'll put the secondary stuff into the B stream, and we'll take a peek at how that works in a little bit here too. So ATSC's 8VSB is fixed at that 19,390,000 bit per second. ATSC 3.0 is not. You can adjust it to do what you want to do with it. And you can adjust it on the fly. OFDM carriers can carry different numbers of bits. They can be fewer for better coverage. They can be more for more payload. They can use high bit rates at the same time that they also use low bit rates. One way to look at this, because we're all a bunch of engineers in here, is, how does this work? Well, if you look at an OFDM, it's a bunch of different carriers, thousands of them. So what we can do is we can modulate this carrier at a fairly low rates. For example, if we do QPSK, we're only peeling off 2 bits per symbol here at the end of it. But let's say we kick it up to 16 QAM. All of a sudden, we're now doubling our data rate. We're peeling off 4 bits per symbol. Well, but you can also do 32 QAM, 64 QAM, 256 QAM, all the way up. But each time you increase the data rate, you also decrease the robustness. But this makes sense when you're working with scalable high-efficiency video codecs. So we've heard a bit about the HVC, high-efficiency video codecs, HEVC. But there's a version of this that says, if I sent out a signal at a fairly low resolution, maybe even a fairly low frame rate to all these devices, that's quite adequate. I can take that signal and I can put an enhancement layer on top of it in order to turn it into a standard high definition or even a 4K image at the end of the day. So the modulation works along in hand with the video encoding when you start to look at scalable high efficient video coding. And this is developing very quickly in the background here. There's another piece in here I won't spend a lot of time on, but it's called MIMO. That's the multiple input, multiple output. You've seen this attached usually to Wi-Fi, and of course LTE uses a MIMO in here, and it's a little hard to get your head around here, but the idea is a pretty simple one, and I'm going to make a gross example, which you are not to repeat to anybody because it's not quite accurate, but it does tell the story. As if I had a transmitter and I irradiated a circularly polarized left and a circularly polarized right hand, just like the guys do at direct broadcast satellite. I can build an antenna that separates the two of these. So let's say I do this with a television transmitter and in my handheld devices, etc. I have an antenna that can look at the difference between the left and the right. Now the problem, of course, is that in the broadcast terrestrial environment, things bounce around, so the sense changes as we reflect. The left becomes right, they start to mush together, but we use that same technique that we did for layered division multiplexing, where we say I have 2 antennas, they have 2 different kind of views of the world in here, and as long as I know the channel information, what the channel looks like, the CSI, the channel status information, I can subtract that from both of these in order to recover the original signal. Whether this will be part of the rollout and how soon that happens, who knows? I mean, potentially you could do both layered division multiplexing and MIMO at the end of the day. Let's talk about the data. Now this is a really interesting and cool part of it. Remember that 1.0 8VSB only had one flavor. So inside the same package here we can have all series of what are called physical layer pipes. And we can take, and that in fact does say radio right there and mobile, we can run at a very low bit rate, that QPSK, and have a very robust signal, and part of this multiplex send this out to mobile devices, etc. But we can also, send standard definition services at like 16 QAM, expecting that they're going to be picked up with rabbit ear kind of television sets, etc. We can pump that up even farther and use it for HD services, et cetera, and potentially 256 QAM. This is taken from the DVB T2 set. We borrowed this almost exactly. That last pipe that isn't labeled here, just think of that as one of those interesting business cases here where a television station can actually distribute things. It could distribute games, it could distribute downloads, it could do all sorts of things that are broadcast out there that make sense to send to a whole lot of people. And because you have this gateway router and it's got a certain amount of storage, et cetera, you can take advantage of that and opens a whole nother business case. This is a little bit of an eye chart, but I just want you to see that there's nothing unusual in here, except for this return channel up here. As ATSC3 does expect, in anything other than granny TV mode, that it's going to be interactive and it's going to hear back from you. And this makes the targeted advertising, the interactive pieces all work at the end of the day. But other than that, it's just pretty straightforward path all the way to the waveform generator. And in this world, when we say waveform, what we mean is the thing that gets generated and is eventually amplified and transmitted at the end of the day. Another view of this that looks an awful lot like that OSI model you had out there. I'll point out a couple of things up here. This is non-real-time transmission is kind of built into it. We've seen Dash. They've encompassed that. Why? Because players and devices generally use Dash, Netflix, etc. So we don't have to invent anything new there. All the other pieces in this is pretty much what you've seen before here. We can also look at it from this view, and that's the neat part about technology is you can slice it many different ways. So these are the basic pieces, and notice how much this looks like HD radio over FM, right down to the interleavers and the pilots and preambles and all of that kind of stuff. So there's nothing new here. And if you want to really blow it up and make it really look like what's sitting in the HD handbook, it looks an awful lot like this. A lot of similarities. So, talk about video. Most important part of this whole thing here is the relative bandwidth demands for the different pieces. Obviously the big one is 4K. If you've got to get that kind of resolution, you're going to burn up a lot of bits. We're going to look at HDR though, because frankly that's just the coolest thing here. The bottom line is that as they start, you learn as you go along here. And this is like the worst slide ever, but I cannot show you an HDR image on a standard HDR screen. This is like in the old days where they used to show how good the color picture was on black and white television sets at home. It can't communicate that at all. But the feedback and the research is that far more important than 4K and high resolution at the end of the day is high dynamic range. You have to experience it. If you get to a show and there's anything out there where they're showing HDR, it will blow you away. I just guarantee it. It is so completely better than what TV is right now that it's just mind-boggling. The reason for HDR, this is an LG slide, is that the current system, we capture this high dynamic range, but by the time we get it home to you in our current transmission, we've squished it down a lot. It goes all the way back to the birth of television. So the argument is if we don't squish it and we give you this wide dynamic range, the pictures are incredibly more beautiful. The darks are darker, the whites are whiter, etc. Mostly a radio audience, we're going to talk about audio, but I'm going to tell you too that in television, as Ann pointed out, there was a part of the surprising result, not to me, because as a television chief engineer, I never got a call about a lousy picture, but I sure did about lousy audio. Audio is ultra important in the television environment. So ATSC3 adds immersive sound at the end of the day. So it promotes all of the 7.1, the 22.2, and we have to introduce you to something called high-order ambisonics. I don't know if that term will stick, but it's kind of cool. And again, what I'm saying with this is that in this world, we got used to hearing sound always coming from us to us at a horizontal angle, and we put our speakers all horizontal. There's nothing in the ceiling or the floor. But what happens if you create an immersive environment, even if that's done psychoacoustically by bouncing sound off the ceiling that's different from the floor, it's a completely different experience here. You hear the helicopters go overhead. You hear the water underneath the couch you're sitting on when you're on the seashore. I had no idea how interesting this would be, but I got to sit through a demo of a very early Atmos Dolby test over at Cable Labs, and I was ready to poo-poo this as well. Yeah, we just adding a bunch of speakers, big deal. But it is so completely night and day. Again, you got to experience this. Both of those are things that when they get out into the market, your neighbor's going to wind up getting it, and there'll be this race to get there. So anyway, it provides all these wonderful, and I'm going to be respectful of your time, happy to send you the deck here, and you can read all of these pieces, or you can look up, especially what Skip Peasy has done as far as ATSC 3 and the audio side of it. This is just to scare you. This is charted where all the speakers are supposed to go when you have a setup like this. If your wife lets you do this, well, tell me what the secret is, because that ain't going to happen in my living room. We're probably going to go to bouncing sound off the ceilings and floors here. All the formats that are supported, again, pull this stuff down, and let's look at multimedia for a second here as we get close to our timeline. You remember Ann had a list of all the things that we were supposed to get out of this, but you know, the multi-view, multi-screen, that 3D content, enhanced and immersed, of all bunch of these pieces, the advanced advertising, really depend on this being, instead of a television one-way broadcasting, multimedia. So what does that mean to? Well, it means that, for one thing, is that this is just as much radio as it is TV. In fact, it's probably a better medium for sending radio programming than anything else out there, especially if the SFNs get built out there. It has this protocol stack that looks very multimedia capable. And let's take a peek at this. So if we turn this on, this is old ATSC 1.0. Everybody got the same stuff, the burned-in stats and the station logo. In ATSC 3.0, you can have different views. You can turn on different things, different stats, everything you can do in HTML5 with internet overlays. Is a hybrid delivery. You can do the dynamic ad insertion, personalized graphics, interactivity, all of the stuff that goes along with that as part of the multimedia experience here. So if I work in radio, why should I care? Well, actually, TV and radio obviously have been tightly linked for a very long time here. By the way, this is the last known TV radio. It basically picked up VHF only here. There was a few car versions out there, and there's no DTV version at the moment. But radio has been playing with pictures for some time, and whether it's Clear Channel's Artist Experience or Ubiquity, who baked in advanced application services over HD radio, the concept is that it's there isn't many limits to doing video on radio, and you kind of do it now with internet and with everything else that goes along here. But most importantly, television is this adjacent technology, just like IT, and what innovation is borrowing the best of each. So radio has donated a lot to TV, TV to IT, and around the circle goes in every which way here. So what if radio goes IP? Well, there's something to think about at the end of the day. And with that, I will talk very briefly about the transition. She talked about lighthouse stations. What that is the idea that everybody will take their signals and move them over to existing ATSC 1.0 stations and probably drop the down to standard definition, etc., just to keep the granny television sets going for a while. And then there will be a lot of channel sharing that starts there, where the stations that don't become lighthouse stations become ATSC 3 stations. And then she talked about the other part of it is receiver seating. In the old days, this is the way I see it coming down. In the old days, if you were a UHF station, you had to give away little loop antennas for the back of the television so that people would hook up their little antenna to be able to see you off the air. I think what's going to happen here is we'll give out the equivalent of dongles or make them easy to buy to make the transition to ATSC 3 easier. Whatever happens, it's got to be infinitely easier than the DTV transition was. So I thank you very much for my time. My email is real easy. It's fredb@nautel.com. And we'll go to the question part of this if there's any out there, and likewise there's plenty of links on Nautel that most of you are used to. We got any good questions?
There's a really good one on here, Fred, from Tom. What kind of information will be sent back to the transmitter over IP? If you have to replace your router, this will make it possible to send back what you're watching looking at over the internet. ISP can have laws about what data they can see, but currently broadcasters don't. What will be done to protect the user from selling their data, etc.?
Wow.
I told you it was a good question.
That is the greatest question ever, and it's a little bit funny in that Chuck and I both have slightly different views of the world and the privacy part of it. I'm going to jump ahead here. There was a test here. I mean, the physical transmission part. You're going to put this bit stream up to the transmitter, and it gets distributed everywhere to everyone. So there's no issue on that one. Obviously, it's that return interactive part and big data and what can happen along that line. But there was a couple of experiments done with viewers and the interactive. Will they give you the information? And the answer is some won't and some will. And I expect that the rules will allow you to opt in or opt out as it does on the internet, that they'll be very, very similar. But what they found out is that a large number of people opted in, and the reason is that it came with a carrot, and that was that if you opt in, not only do you get the targeted advertising, but you also get the coupons and the deals at the end of the day. And a lot of people seem to like that. That is a great question. Is there any others in here?
Yeah, DVB-T2 has an 8 megahertz bandwidth, which is scalable.
Yep.
Question mark. Yeah, that's true.
Yeah, right, and there's some conversation kind of in the back rooms as one of the things that some people are worried about is the way they built the pilot signal for ATSC3 is you could take it down to 5 megahertz, and maybe you don't want the FCC to do that at the end of the day. But there's also a flip side to it. You can bond channels under ATSC3. So if 6 megahertz isn't enough, you can use 12. You can just marry the two together. And they're actually working on that part of the standard and the testing right now.
Okay, another couple questions. Will each station put out a kind of app so that they can interact?
I would expect lots of activity along that line. My imagination goes wild with what will happen when the marketing and advertising people get a hold of this tool. I suspect that there will be an awful lot of, it used to be that station viewer contact was through telephone and mail, and I suspect that and a lot of bit internet nowadays. But when you're actually sitting there in an interactive environment, I suspect that the connection between the customer, the viewer, and the station really increases dramatically. But it's so hard for me. I mean, I imagine it being an extension of the internet at the moment, but there are a lot of people out there dreaming about all the pieces. One that I find really fascinating is PBS and the opportunities for educational television, is what happens when you combine ATSC3 along with computer, internet-type learning environments. I think that's going to be very cool.
Make the classroom unnecessary.
Yes.
Will ATSC still be in 6 megahertz passband?
Yeah, we kind of talked about that. I mean, it technically doesn't have to be, but obviously given the domestic structure, and keep in mind that ATSC 3.0 is a candidate as a world standard. How likely that is, I don't know, but it's the next step beyond what DVB-T2 is, which is a little bit patchworky compared to where ATSC 3.0 is. It could be that it's used in a bunch of different environments, so the actual bandwidth is just a knob that's part of the equation here. It's hard to say who's building what modulator or will build out what modulator, but if there is a market in the world that's 8 megahertz, even 10, or some that are 1 and 2, I suspect that they'll be able to, that they will build out modulators to support it. I'm not sure you can go below 5, to be quite honest, because of the signaling requirement. I'm just not smart enough to know that one.
Yep. Okay. One question. With this, it seems like there's a back channel, which means that the broadcaster actually gets its own audience measurements in real time. Does that make Nielsen obsolete?
There is a regulatory piece with this. Personally, I came out of the cable industry. Along with broadcast, I've bounced around a few times, but if you remember back when launching all sorts of cable channels, it was a natural progression from my career. But what I learned in there is that with addressable set-tops is that you could see what everybody was watching at any given time. All this data would come back, and we could see what was going on there, but regulatorily we could not share it. So while we knew, because this was the central authorization facility for this very large chunk of the world, what was going on, and we would see the Nielsen ratings, et cetera, and notice that there were some inconsistencies over time there. I think it's more of a regulatory question. It's certainly not a technical question. This could happen.
Okay. Another question. So in ATSC, in fact, in most of the digital systems out there, you can dynamically, or you can allocate dynamically the bandwidth to multiple channels carried on the same transmitter. Are there any additional benefits to ATSC3 in this? Does it get any easier to do?
Yeah, it does. I mean, one of the hassles with ATSC 1.0 is that if you wanted to light up another service, you were stuck with the television's ability to rescan. So let's say you just wanted for certain periods of time to have this service up and running. Maybe it's a foreign language channel. But then you got to the Super Bowl and you didn't want to spend any bits running any of these sub-channels. You wanted the most beautiful, gorgeous picture out there. There are significant disadvantages to trying to do bandwidth allocation on the fly inside ATSC 1.0. Inside 3.0, dynamic changes are part of how this environment works. So when the Super Bowl comes along, you can blow out the 4K, 16K, high dynamic range, let all the stops out for that beautiful super picture, and then at 3 o'clock in the morning, pull it all back in so that you can do data distribution, for example. Baked
Great.
in.
That's the questions we've got. Thank you, Fred.
Thank you, and thank you for joining the webinar here. It's been a joy. Oh,
Well
and
done.
I'm supposed to remind you that this is available on a YouTube channel. So.
And we will be providing a taped version of this webinar, if you'd like, on our own Nautel webinar website on our home page, probably within 24 hours or so.
Thank you very much.
Thanks, Fred.